Good morning, class. Today we're going to continue our discussion on autoregressive integrated moving average. And we said that let's have a quick review. In order to use ARIMA as a methodology, we have to transform our data into a stationary data series, stationary in mean and stationary in variance. After we do transformation, we can check via a plot if the data no longer exhibits non-constancy in mean and non-constancy in variance. But we can also do statistical tests. Okay, last time we learned about the ADF test, the augmented Dickey-Fuller test, and also the KPSS test. And also from the URCA package, we also did the URDF test. So all of this we can use, and there are other tests to determine if our transformed data or transformed time series is already stationary. Okay, the next step after we transform the data, after we have tested if it's stationary, then the next step is to plot the autocorrelation function and the partial autocorrelation function. Now, I dare say that in these times, we actually do not need to plot the ACF and the PACF. If the objective is for us to generate an ARMA model, okay? Because the plotting of the ACF and the PACF is primarily used to determine the order of the AR or the order of the MA or order of the ARMA process. So it's used to identify the model, the ARMA model that we're going to use. Okay, and I said that there is difficulty in using the ACF and the PACF. There are guidelines, but it will really require an iterative process, a trial and error. And once you have identified a particular model, then you test it, and then you have to do another model and compare. After you have several models, try to compare which among the models is best using certain criteria like AIC, BIC, SBC, etc. Okay, so at this time, for such a time as this class, we don't need those because we have technology, we have tools that will do that for us. But still, despite that, we would like to at least see how the ACF and the PACF looks like. Okay, so let's now go here. Okay, so last time we discussed how the ACF and the PACF looks like. In order to determine if it's an AR process, we look at the PACF plot. We said that there should be how should the PACF plot look like in an AR process? Anyone, please? What did we discuss last time? How will the ACF plot look like and the PACF plot look like if it's an AR process? You can unmute yourself or you can chat, please.
Sir?
Yes.
I can try naman po. So
Yes,
if
sige,
it's
thank you.
if it's an AR process po, yung ACF plot would be yung wait, what's it called again? Yung tail off.
Yes,
And
okay.
PACF po, it would be a cut off.
Okay, thank you, Rhea. No? For an AR process, okay, let's say AR1, it will indicate in the PACF a cutoff at log 1. So log 1 will be significant. Okay, that's an AR1 process. And also the PACF should be a tapering. Okay, tailing off, tapering off, slow decay. Those are names that used to describe such kind of behavior for the autocorrelation function. Okay, so that's how your AR process will look like. So if you plotted your ACF and the PACF, and the plots of ACF and PACF look like that specifically, then you can start with trying an AR1 process. And we have defined what an AR1 process. Diba? An AR1 process is you describe your time series based on a log 1 value of itself. Okay, you have a y sub t minus 1 plus a certain coefficient. A coefficient phi sub 1 times y sub t minus 1 plus your a certain error term, okay? All right, so we have discussed that in the past. Or if it's an MA process, on the other hand, let's say an MA1 process, there will be a significant spike at log 1 for the ACF, okay? So it will cut off or significant spike at log 1, and then the ACF will be a tailing off, a slow decay, okay? All right. For an ARMA process, it can look like a both tailing off at the ACF and the PACF. So those are possible plots for your ARMA process. Okay, so before it will really require some patience and some practice for one to come up with the correct or acceptable model for your time series. But now, class, that's no longer needed. Okay, now you can plot the ACF and the PACF using technology. We'll use R. Okay, so let's do this. I think I blanked this in the RMD file that I gave you. Is this blank, class? This portion here? Feedback, please, class.
Yes po, sir.
Okay, in the interest of time, okay, kasi medyo medyo naghahabol tayo, no? I will share this code with everyone, okay, so that you can just copy it. Okay, I would not usually do this if we are on time, but we're trying to be abreast with the other section kasi our post-it cloud work in the second period. All right, so what are we doing here? This function, this is partition. Partition our matrix containing one row and two columns. Okay, so if you want to plot and then you want the appearance to be one row and two columns, you use this. Par MF row is equal to 1 and 2. If you want, the first number here refers to your row, and the second number refers to your columns. Okay, so 1 by 2 row by columns. Okay, so then let's create an object called A1, and then we're using the function ACF. Okay, so what's the function ACF? Autocorrelation function. Okay, ACF stands for autocorrelation function, and then we would like to create an ACF. And what was the data that we were using last time? I hope it's still here. Yeah, DLBUD. Okay, quick question, class. What's DLBUD, class? How did we define this to be? The DLBUD. Yes, Adi?
Difference and log ng bud po, sir.
Correct. Thank you, Adi. That's correct. So this is the difference log of the time series bud. And let me ask you again, class. What does this represent actually? If you were getting the difference of the log of a time series, what's that? That's actually your letter R, class. Okay, that's your, yes, thank you, Glenn. That's the returns, log returns to be specific. No? Thank you. That's the log returns of your time series. And oftentimes, class of finance, what you're looking at is not actually the price itself. Okay, the price of the stock, whatever price you're looking at, you're actually more interested in determining or in modeling the returns, in particular, the log returns. So this is a very important quote-unquote object, yung DLBUD na yan. Whatever time series you're working on, oftentimes, as I said, there are many researchers, many studies that really focus more on modeling or understanding or finding associations with the returns. And I think we discussed last time that for returns, we can use the daily returns function of QuantMoon. Okay, or we can use this. It will generate the same thing. Okay, so let's plot here the autocorrelation function for our bud returns. And then we can use the log.max. That will be 30 logs. You can use other logs. This is just arbitrary. It can be 12, it can be 16. Usually, ang ginagamit, 16 or 24 or 30. Okay, so it's just arbitrary. So let's plot, and then let's plot this. Okay, let's take a look. Let's run everything because you have 1 row and 2 columns to plot both our autocorrelation and partial autocorrelation function. So let's run this, and then you'll have the plot. Okay, here, class. Okay, can you see my screen? Can you see my screen, class?
Yes,
Okay.
sir.
Okay, thank you. So this is what I was telling you about. It's not really that easy to try to guess a model. Say, for example, sa ACF, no? May mga significant spikes dito. Sa significant spike at log, I think that's log 2. That's log 2. Significant spike at log 2. And then may significant spikes pa tayo sa longer logs, no? Okay, but I'm not sure if this you can treat it like a slow decay or tailing off. Kasi ang tailing off, class, pwedeng positive and negative yun, alternating. Okay, so pareho din sa sa PACF, no? It's almost identical, the plots of your sorry, pareho palang PACF to, no? My apologies. Pareho silang PACF. Okay, how about the ACF? Andito yung ACF. Bakit hindi nag-plot? Alright, something's wrong with my... ito pala, class. So yung ACF niya, tinan nyo, no? ACF. Okay. Ito yung sinasabi ko sa inyo, class, is what I'm saying na this is log 0 to, no? Kasi perfect correlation. So you're getting the correlation of the DL bud with itself. Kaya 1 yan, no? So this is not actually, quote unquote, a significant spike. There seems to be parang parang barely significant to, parang negligible to eh. So there seems to be sa ACF parang walang the ACF does not tell us anything. Okay? So if the ACF, if we consider this as significant spikes, then medyo mahirap kung ano yung log, ano yung order na gagamitin natin. So this is just an example of why it's important, why it's difficult to determine or to determine a possible RA or MA or ARMA model for our time series based on ACF and ACF. Okay? So whether you're looking at ACF or PACF. For some data, class, it's very easy, very apparent, very obvious what model is best. But for some, you'll be hard put to come up with an appropriate model for that. So that's why it's really an iterative process. So you just keep on trying. Okay, so we will dispense with that, class. But there's another way to plot your ACF and the PACF. So let me just share this with you also. You can use this. So they come from different packages. Okay, so let me just share that again. So you don't have to write. Kasi naghahabol nga tayo, no? So here, same thing, partition, 1 row by 2 columns. And then this is ACF function. Okay? So if you want to check saan galing function yan, di ba? Question mark dito sa natin. Okay? ACF, this one. Oops, control enter. And sa help natin, it will tell us so saan galing siya. ACF, this is coming from FINLYTSK, Financial Time Series package. Okay, if I click this, ACF class, no? FINLYTSK, and this is the syntax you can use. Okay, so if you want to just be aware, pwede lagay dito FINLYTSK, sorry, TS. at the onset, it might be good to write yung namesake niya so that you know which package is that coming. The other one, I forgot to mention, ACF. So this is coming from which package? Okay, this is from the stats package. That's why we didn't need to download any specific package. Yung FinTS class, we already, if you take a look at our packages, yan siya, no? FinTS, we included that in our packages. Okay, so let's run this, yung ACF na capital A and PACF na capital P. Okay, let's run this and see how it looks like. Okay, so you have a separate, hindi siya nagsama, no? Oh, wait, sorry, PACF. My bad, hindi pala galing dun. Okay, sorry class. So yung PACF comes from your forecast package. Okay, apologies for that. Hindi ko kinakabisado, no? Okay, I should have memorized that already. FinTS, your ACF, and for your forecast package, your PACF. So let's run this again. Okay, so meron na, no? So notice yung plot natin, one row, two columns. Okay. So take a look at the ACF, just like above class, it's quite difficult to really pinpoint. If you will look at the PACF, significant spike at 1, and then at 3, and then at 5, and in some larger lags, no? Okay, may mga significant spikes tayo dito. It might tell us of perhaps seasonality, we don't know. Okay, so if we're going to look at this here, it might suggest that pero yung ACF kasi halos pareho din, di ba? No? Halos parehong behavior nila. So we might be looking here at, well, we cannot be sure whether it's an AR process, no? Or maybe even an MA process, or pag-ARMA kasi, usually ano siya class, yung slow decay or slow tail of both sa ACF and the PACF. So it could be like that, no? Pwedeng ARMA siya, pwedeng AR, or pwedeng MA. So in this case, the ACF and the PACF plots are not particularly helpful in this case, no, in helping us to determine. So talaga magta-trial and error tayo dito. Okay, the good thing is, okay, one more thing class, ito. The TSM package, there's also another package. Remember yung TSM na to that we had to install separately? Kasi may mga functionalities din siya na maganda. So for example, ito AC lang, autocorrelation, it will already generate both the ACF and the PACF. Okay, this one class, I'm sure you can easily type that. Okay, just add that to another code chunk. And then please run it, class, and see what happens. What do you get, class? We use the AC function of the TSM package. It will generate both the ACF and the PACF. So we didn't need to run both the ACF and the PACF function. Only AC will give us the combined ACF and the PACF result. Okay, so could you kindly chat, please, if you were able to run this code? I'd like to check and see. Kindly chat, please, if you were able to follow along with this TSM package, yung AC function niya. Kindly chat, please. Okay, thank you. Let's wait for the others. Okay, I'll give you a few more seconds, class. I only have so few responses. Sana makakalahati mo lang tayo, class, na responses. Okay, good. A few more seconds. Hindi pa tayo ng lahati. How about the others, class? Wala pa tayong 50% ng responses. Okay, thank you. All right, good. Salamat ha. I just want to make sure that you're following kasi useless yung discussion natin kung hindi nyo pala nakukuha, no? I would appreciate you commenting or asking questions. Okay, so your plot would have looked like this. Zoom ko na lang siya. All right. Okay. So it behaves similarly. No? May mga significant spikes tayo at certain lags. So halos pareho siya. So ano to? AR process ba to? So it doesn't look naman na slow decay, no? It looks like significant lag. So mukhang significant dito sa ACF, which indicates that this could be an MA process, or mga significant spikes dito sa PACF, which could indicate that this is an MA process. Okay, so that's why sometimes, as I said, during our times, this was really quite difficult. Kasi medyo magiging magaling ka dapat sa pag-determine, no? Kung that's why it was always really an iterative process, trial and error. No? Okay. So sabi ko nga dito, it may be a challenge to determine kung ano yung model na pwede natin gamitin. So enter this class, enter this function, auto.arima. Yan ang kagandahan, class, with such technology as R, that already frees us. Pinifree na tayo, no, sa difficulty ng in determining kung ano yung model natin. So let's just check first ano yung auto.arima. Okay, let's just run this. Okay, ito class, auto.arima. So this is from your forecast package. Okay, sabi dito, returns the best ARIMA model. Okay, so remember I told you that you will have to generate several processes, AR1, MA1, AR2, ARMA11, etc. And then you have to compute for the AIC or corrected AIC or the Bayesian information criterion, okay, to determine which is the best of those ARMA processes that you have computed for. Okay, so what follows is that the lower the AIC, the better the model is, so, because it means that lower information loss. All right, so this is the syntax. Okay, quite a long syntax. Okay, we will not really need everything there. Okay, dami, no? Tapos may explanation dito, tapos I think may example dito. Okay, so you can use this for example. Okay, meron ditong data yung WW usage. Okay, dito nag-auto.arima siya. All right, so let's go back to our example. So how does our example look like? Okay. All right, so let's go here, class. Let's look at this first function. So we're creating this object called mod1, model1, and then we're using the auto.arima function, and then we ask R to get the best ARIMA model for the log returns of BUD or DL-BUD. And then we ask R to summarize it. Okay, so let's run this. Okay. All right, then I'll request you to please chat. If you were able to get the output, I'll flash again the formula. I didn't give this to you, but it's a very simple formula. Ano lang siya, class? Auto.arima lang. And then yung time series. And then in the help function, di ba, we saw you can still identify other parameters that you might want for R to compute for the ARIMA. Okay, kindly chat, please, if you are able to run this code. So awaiting your chat, please. Okay, thank you. Okay, si Rhea pa lang. Let's wait for the others to key in their response. Waiting for the others, class. Yung iba, class? Wala pang response? Stopping for a while and waiting for your responses, class. Okay. Could not function. Anong gagawin yung class if you could not find the function auto.arima? Di pa kayo nag-library siguro. What do you do? Any suggestion? If you run auto.arima and it says cannot find, what do you do, class? Any suggestion? Okay, we have here. Yeah, okay. Yes, thank you, Adi. Paano natin i-check, class? Diba mag-help tayo dito, diba? Help, auto.arima. Kasi makikita natin, class, we can see what package this is from. Okay, auto.arima. So, and so this is from the forecast package, class. Baka hindi nyo pa in-install, class, yung baka hindi nyo pa nararan to. No? Kasi andyan yung forecast, no? Library forecast. Okay, so that's the answer there, why auto.arima is not running. Okay? All right, thank you, Michael, for that question. Okay, let's wait for the others. Let's give them a few more seconds. Okay. Pakonti ng pakonti nagre-respond, class. Kamusta na? Ano nangyayari? You have to tell me, class, kung what's happening. Okay, thank you. If there are any concerns, I appreciate those who ask questions. No? Kunyari, a while ago, si Michael yata, he asked, hindi nag-run yung auto.arima. So what do we do? Diba? So, alamin natin kung saan galing package yun. Most probably, hindi pa na-load yung package yun. So, i-require natin. Kung hindi pa na-install, syempre, install that packages. Okay, so let's see. Although I noticed, class, na kumukonti yung nagre-respond, no? I hope we get a higher percentage next question. Okay, so let's go here. Let's go to Okay, we're done with that. Auto.arima tayo. All right, I'm getting this result ng auto.arima class. So what is this telling us? What's our model class? Okay. All right, I saw some comments. MA4, yes, thank you. You're correct, no? So our model is MA4. Diba? So if we were just looking at the PACF and PACF, diba ang hirap, no? Although MA4 siya, ibig sabihin, we look at your ACF, diba? Although dito, mukhang significant spike at 1, here at 4 also. Okay? So, and we were saying a while ago, maybe this is an MA process or an RA, AR, or an ARMA kasi hindi clear, di ba? So, si R, sabi niya, this is our model. It's an ARIMA 004. Okay? So, what's our equation, class? By the way, class, if you recall, what's another name for ARIMA? ARIMA 004, class? What's another name for ARIMA 004? It's equivalent to what? Class? ARIMA 004, ARIMA 04, pati MA4. Yeah, thank you. Thank you, Michael. Thank you, Rhea. You're correct, no? So it can be ARIMA 004 or ARMA 04 or MA4. No? And how will our equation look like? So our equation will be, since we're modeling difference log of BAT, okay, sub t, this is a time series. So this is our model, is equal to, all right, you have 0.0031 times what, class? Times, anyone? This one, okay. Times what, class? Times, this is MA1, ba? MA1 yan. So ano yan? Let's see, somebody, epsilon, yeah, thank you, Michael, you're correct, no? So that's epsilon what? Kompletuhin natin. T minus 1, di ba? MA1 yan di ba? First lag component ng error term. So itong MA2, so we have, sulat ko dito, plus 0.0478 times epsilon t minus 2. And then plus negative 0.0259 times epsilon t minus 3. And then minus 0.0361 times epsilon t minus 4. And then sa unang-una, you have dito, I'll just put it here, epsilon sub t, no? Plus. So you should always have the residual, the error at the current period. Okay? So this is our model, class. This is our model. It's an MA model, MA4, so 4 components of your predictors. In this case, your error terms, right? And then plus the error at time 1, which is epsilon sub t. Okay, let me pause for a while. Any questions so far, class? Were you able to get the MA4 model for the log returns of BUD? Okay. Let me... Okay na ba ito, class? Any questions? Any clarifications dito sa ARIMA 004 natin?
Hello, sir.
Yes?
Question.
Yeah, sure.
Kapag AR, Y sub T, no?
AR, Y sub T. Yeah, our Y sub T is D log bud, no? Okay, this is what we're modeling, di ba?
Yes, sir.
Okay, kaya I could have used Y sub T here. Okay, Y sub T. But since specific yung minamodel natin yung log returns ni bud, then this one. Okay, if I delete this class, magiging ano yung model natin? Diba? Magiging hot yan, no? Kasi wala nang error term. Magiging yung predicted value or forecasted value itself. Okay, anyway, and we'll still continue to discuss this. All right, any questions, class? Any other questions? Okay, no questions? Sige, let me... Okay, now we can use also the same function class kasi isasali natin tong trace is equal to true. Okay, I'll give you a few seconds to run this, same as above, kasi we're just including trace is equal to true. Kindly do that, please, and tell me what you get. Kindly chat, please, what you are getting. If we include trace is equal to true. Okay. Rhea, kindly share your answer to everyone, please. Okay, there were multiple models shown. All right, you're correct. Thank you, Rhea. So trace is equal to true imposes that are show us the list of models that was tried, no? That was where R performed a test on those models. Yeah, and it chose the best model. Correct. Thank you, Michael. You're correct. So sabi ni Rhea, it gave us a list of the models, and then sabi ni Michael, it gave us the best model. You're correct. Both of you are correct. So let's run this. Okay, ito yun siya, no? So you notice that R takes on several models, no? So you have here, for example, ARIMA 202. Okay, naglagay siya ng AR component saka MA component, which also makes sense kasi parang ano parang may significant spikes dun sa AR sa yung AR kasi 'di ba manggagaling sa PACF. Tapos itong MA component naman manggagaling siya dun sa that's for the MA, no? MA with non-zero mean. Ibig sabihin walang intercept, and then you have this AIC negative 18079. So it gives us a grocery list of the different models. Sinusubukan din niya with zero mean. Ibig sabihin ng with zero mean, walang intercept. Okay? And with zero mean, with zero mean, ibig sabihin, walang intercept. With non-zero mean, ibig sabihin may intercept yan. All right. So, ano daw yung best model? Turns out that based on AIC, which is this one, ito, no? Ito yung mga AIC na ginamit niya. The lowest was 18084.61. So if you try to compare that with the others, 18084, ito pala, sorry, ito. This one. With non-zero mean, no? Okay, meron kasing with zero mean, meron kasing ARIMA 004 with non-zero mean. Ibig sabihin may ano pa to, may mean value. 18084. Ito naman 18086, which is lower compared to the ARIMA with non-zero mean. Okay, so R suggests that we use this model, ARMA 004. Okay, so pareho lang dun sa sa kanina, no, yung trace, yung walang trace is equal to true. And then the coefficients are also the same. Okay, so now we know how R chooses between the different models that it uses. Ang pinakamali dito, as we said, it will be based on the least lowest na AIC, which in this case among the list is 18086.02. Okay. Pachat, please, class, please, if we're okay so far, kung clear ba, kung nakakahabol sa explanation or not. May I request for your feedback, class? Okay, good. Thank you. Thank you so much. Yan. Maganda, maraming nag-respond, no? Okay, appreciate your response, class. It gives me confidence to continue on. It makes me believe that you are getting the explanation. Okay. So here, class, okay, what we'd like to know is if we're coming up with an AR process, an MA process, what should be the attributes or qualities of your coefficients, yung phi1 natin or yung theta natin? Okay, di ba? If you recall, sabi natin that an AR1 process, okay, let me annotate this once again. Okay. By the way, no? So we said that an AR1 process, if you recall, class, is AR1. Kung without mean, it will be equal to phi1 times y sub t minus 1. Okay. Sorry. So this should be y sub t. Y sub t is equal to, meron akong column dito. Y sub t is equal to phi1 y sub t minus 1 plus your error term. So, and ARP, as we know, quick review lang, is equal to y sub t is equal to, so assuming natin na no mean, is equal to phi1 y sub t minus 1 plus phi sub 2 y sub t minus 2 plus plus phi sub kung p minus 1, no? And then y sub t minus minus p minus 1, and then plus finally phi sub p times y sub t minus p. Then you have, of course, plus error term. Okay, class, are you getting me, class? Konting review lang to. Actually, class, you can, let me just show you. Itong phi sub 1 na to, kasi you might be confused because others will, itong y sub t minus 1, class, it can be named as b y sub t. B means backward operator, backshift operator. Pag sinabi natin B, ibig sabihin, we're taking the log 1, B. So this is B1, ibig sabihin log 1. Y sub t minus 1 is equal to B y sub t. Y sub t minus 2 is equal to B squared, ibig sabihin 2 times na yung log y sub t. Alright? So pareho lang yan kasi you might see in other instances, itong y sub t minus 1 yan, papalitan ng b y sub t. Ito papalitan ng b squared y sub t. Itong yung y sub t minus 3 papalitan ng b to the third y sub t. And then you can actually factor out yung b, di ba? Pwede natin ma-factor out yung b para magkakaroon ka ng parang kwadra ng equation. Okay, and you can now solve for the coefficients of your B. Pwedeng gamitin yun. So, of course, yung AR sub P, sorry, I'm writing here, no? AR sub P can be written as equal to, assuming no constant, it's actually the summation, no? The sum of what? Phi. And let's call it phi sub I, okay? And then y sub t minus I. And then we have plus yung error term natin, where I ranges from 1 to I is equal to P. Ba? Sorry for the writing, no? So that's phi sub I, y sub t minus I. Okay, yung I ranges natin from 1 to P kasi AR sub P. Okay, let me pause for a while. I know I was quite talking Greek, but allow me to let you ask questions if you want. Okay, if not, class, kindly share naman kung clear so far yung mga pinagsusulat ko doon. I'm just referring to some notations kasi baka pag nagre-research kayo, no, makakita kayo ng B. Ano kaya yung B na yan? So that's your back shift operator. As I said, yung log 1 ni y sub t minus 1 is equal to B ng y sub t. In other words, kinukuha mo yung log 1 nito. Okay, B sub 1. Pag y sub 2, t minus 2 naman, it's B to the level 2 times y sub t. Okay, no feedback yet, class? Waiting for your feedback. Are you okay so far? I don't mind repeating the explanation, class, if you so want me to repeat. So I'll appreciate some honesty here. If you want me to repeat that, what I just said, then AR1 ba yung first equation? Is this one you mean dito? Yeah, ito AR1, no? Yeah, this is y sub t to is equal to phi sub 1, y sub t minus 1. Log 1 lang to, plus a certain error term. That's why this is an AR1 model. Okay, Michael, did you get that? Okay, thank you. How about the others, class? Wala pa kayong feedback na nakukuha ba, naintindihan? Okay lang, class, kung hindi naintindihan, ulitin ko. No problem. We're here to really learn. Yeah, okay. Ulitin ko yung back shift operator. Sige, I think let me use a Word file. Bukas ako ng Word. Exit muna ako. Clear ko muna to, no? Okay, let me open a Word file para doon ako sumulat, no? Ang daming ang dami nakabukas. File. Okay. So let me write once again, no? Okay. All right. So sabi natin, di ba, an AR1 process is, saan ba to draw? Okay. So an AR1 process, AR1, no, is defined as y sub t is equal to, let's just make it no min, no? Wala yung alpha o wala yung beta null para mas mabilis lang. Is equal to phi 1 times y sub t minus 1 plus epsilon sub t. Okay, so this is your AR1. This can be written as y sub t is equal to phi 1 times, itong y sub t minus 1, class, can be written as backshift operator. B1 yan, understood, kasi isang log lang naman. Okay, y sub t. So I'm replacing y sub t minus 1 with y sub t. So our log values are expressed in terms of y sub t. Okay? Plus epsilon sub t. So this actually, you'll see some equations na ganito, no? Y sub t minus phi 1 b y sub t is equal to your error term. Yan. Okay? And then just y sub t to, no? You can also factor y sub t times 1 minus phi1, okay? So, and then you have your b here, no? Okay, is equal to epsilon sub t. So this is another way to write your AR1 process. I'm just giving you a sample, no? Okay, in general class, di ba sabi natin ng an ARP process, ARP is equal to, again, phi sub 1 times y sub t minus 1 plus phi sub 2, y sub t minus 2 plus dot plus your phi, then this should be p minus 1, second to the last, no? P minus 1 times y sub t minus p minus 1, second to the last, and then finally plus phi sub p, yung last na p, and then this is y sub t minus p. But t minus p, t minus 1, t minus 2, hanggang t minus p, and then plus a certain error term, epsilon sub t. Okay, so you might see also this being written as AR. By the way, this is this is so this is your y sub t, di ba? Your y sub t expressed as an ARP process. Okay, so we can write this as y sub t is equal to, okay, we just get the sum, no? Sum, ang nagbabago dito yung phi at saka y sub t. So this is phi sub I, y sub t minus I, okay? Where I ranges from 1, doon tayo nagsimula, hanggang I is equal to P. Hanggang P. And then we add the plus error term. Okay, so this is your ARP process. Okay, so I just showed you, class, how this can be written. Of course, we can replace this by B, no? So which is equal to summation ng phi sub I, okay, and then B, okay, T sub I to, okay, B to the I, no, ng y sub t plus epsilon sub t. Kung ilan yung log B sub I, B to the ith power. Okay, so I know, class, that kasi since first time yung nakita, no, I just want you to be aware na whether RA or MA, yung log, class, can be written with a backshift operator with B. Okay, class, clear ba to? It's just a matter of notation. Clear ba? Ano naman, class? Pakisabi naman kung okay lang or nakakalito. Okay, thank you, Richmond. How about the others, please? Okay, thank you. Thank you for your feedback. Okay, punta na tayo dito, class. Balik tayo sa R natin. Okay, saan na tayo? Wait. Here. Ay, mali. Ito sa R. Ito. Oops. Ano to? Oh, this is data visualization. Oh no. Asan na isang R ko? Bakit nawala yung isang R? Did I close it accidentally? Okay, na-close ko yata accidentally yung isang R Studio. So let me just open. Kaya itong advantage, class, ng na may project ka. Madaling buksan. Sa project kasi natin yan. Ay, no, sorry. I was using Post-it, no? Oh, kaya pala sabi ko na wala yung isang R Studio ko. Yung pala, we're using the, I'm using this one. Okay. All right. Now, so dito na tayo, no? Okay. Let's first simulate. Gagawa tayo ng simulation. we are going to create, sorry, 500 lang to. 500 muna. We're going to create an AR process, an MA process. So pwede natin i-simulate siya. Magpapakreate tayo ng dataset. Tapos titingnan natin kung ano yung model na yon. Okay, so okay, do you have this class? Check nyo nga class. Yung notes na binigay ko sa inyo. Kasama naman to, no, di ba? Paki-chat please kung yes, if you have this. For AR1 and MA1, you have that class? Wala? None? Okay, sige, sorry. Okay, so let me share this with you. No? Control C. Sabihin nyo sa akin, class, kung wala yung ano para... Okay, so what am I saying here? Actually, ito yung question ko sa inyo kanina, no? Yung pag-AR process class or MA, if we're asking R to generate the coefficients, phi1, phi2, etc., may characteristics yun. Okay, for example, for an AR1 process, A1 is your phi1, no? Ito yung phi1 natin. Para hindi nakakalito signal. Tingnan ko lang $. Natin kung saan na siya? Ayan, class, no? Ginawa ko inline text, no? So, $, okay? Phi sub 1 to, no? This one. See? Okay, $, if you want the that special character to appear, ayan, put it between dollar signs, no? And alam naman natin na kapag Greek symbol, slash, then phi, and then _1. So, phi sub 1. And ito naman, class, this is your, lagyan natin dito, $, slash, theta, 1. Okay. So, this is your theta sub 1. This is your coefficient for your, okay. Lagyan ko nga dito ganyan. All right. Okay, so you can see here, for an AR1 process, whatever the value of your phi1, the coefficient of your log1, it should not be greater than 1. Okay, nor less than -1. So dapat between, yung absolute value niya should be less than 1. Yung ibig sabihin ito. No? Also for your theta, the absolute value should be less than 1. Hindi pa pwedeng lumaki kaysa 1 yung mga coefficients natin. And there's a reason for that as we go on. No? The coefficients of the AR1 and the MA1 can't be greater than 1 and less than -1. Okay, so let's try this. No? Okay, so tingnan niyo muna tong code na to. Siguro I'll ask you to write this para ma-practice nyo naman. So A sub O, let's create this constant, no? A sub O is equal to 1. And then magsiset that seed tayo. I think I have explained this to you. Set that seed para pare-pareho tayong randomly generated the numbers. And then let's first create an AR1 object, small. Ibig sabihin nun, class, yung AR phi natin, ito C, is 0.1. So take a look at this code. Okay. So here, we're creating this object, AR1.small. Small siya kasi nga, class, yung phi1 natin, we'll just make it 0.1. So we're using this arima.sim. This is arima.simulation. Your n is equal to 500. Okay, 500 observations lang. Model is equal to list. Ano ililist natin? AR lang, no? AR. And then the AR is equal to 0.1. Ibig sabihin yung class, AR1 lang siya kasi isa lang coefficient. Hindi siya ARMA, hindi siya MA. So AR is equal to 0.1. It means, class, that the coefficient of phi1 is 0.1. And then we define the standard deviation, SD is equal to 1. Let's just peg it at 1. And then we add the plus, yung constant natin, which is 1. Okay, we defined it to be a sub 0. All right, and then let's ask R to plot whatever this is. So let's run this together. Control Enter. Okay, and then we now have a plot. Okay, this is the plot. So this is your AR1 that's small. You notice, class, that this is an AR1 process. Diba? Yung generate natin na arima.simulated, arima.sim, that's an AR1 process. So we expect the plot to be stationary. Diba? Take a look at that, class. Stationary siya. Okay. Now, if I replace this by, let's say ARC is equal to 1. And then, sige, mamaya na. I-run muna natin to, no? And then let's use the, class kanina nag-auto.arima tayo, no? We can do that. Here, I'm using another function, and this function is called arima. So this function will allow us to determine the model. Model ni AR1.small. We know that AR1.small was created by an AR1 process, no, with phi is equal to 0.1. So let's see what happens. Okay, so using the forecast package, in particular the arima function, the object is AR1.small, yung generate natin, yung create natin, di ba? Ito yun. Okay, if you take a look, andi dito siya, no, AR1.small. Okay. If we get the, check lang natin, class, just to be sure, dapat pare-pareho tayo ng dapat pare-pareho tayo ng, kunin natin, class, yung let's get the first 6 observations na lang, ito. Before we plot, kunin natin head AR1.small. Can you please get the head? And let's compare. Yan. Okay. So first 6 observations, 1.2055, 1.52. Paki-chat, please. Kung pare-pareho tayo, class. Do we have the same observations? Ayan, 1. Thank you. Yes. Who is this? Yeah. Sino sumugot kanina? Just to like to acknowledge. Michael, thank you. Yeah, same. Okay, same. Good. Bakit same, class? Kasi nag-set that seed tayo. Okay? So this is your data. No? That's your AR1.small. And if we use arima, kasi yung arima, class, di-determine niya, it's like yung auto.arima kanina. No? Pero ito, ibang function coming from forecast function. So ano yung pinapadetermine natin kung anong model? Yung data natin si AR1.small, then we define order is equal to C100. Ano yung ibig sabihin itong C100 na to na order? AR1 process is 1, 0 difference, 0, moving average. No? So this is sinasabi natin, paki-define nga yung arima process niya, yung arima model niya, using AR1 process. And then include that constant is equal to true. Ano to, yung intercept? Kasi may tayo, di ba? May intercept tayo na 1. Ito. Yung AO natin, that's our intercept. We pegged it at 1. Diba? Of course, you could have used another value. But let's run this, class, and let's see. Okay. So ito yung na-determine niya. No? AR1 niya, ang AR1 component is 0.18. No? Ang mean is 1.00. Yung mean malapit. Pero yung AR1 component medyo malayo, no? 0.18. No? Okay? Okay? Why is this so, class? What do you think is the reason why? Yung model natin, AR1, di ba? Yung sinimulate natin, AR1. Pero ang lumalabas na arima natin, 0.18. What do you think, class? Why do you think there was a discrepancy? Okay, first and foremost, simulated lang yung value natin kanina. No? Second, Our sample size is quite small, 500. No? 500 lang siya. If we increase this, sabihin natin, gawin natin, let's make this as 100, ano yan? Let's make it 100,000 class. Ay, sorry. Dito ako sa, doon muna tayo sa ano, sa small, no? Okay, let's make it 100,000 observations. Yeah, 100,000 observations. So let's run up to here. Wag ko na kunin yung head. I-comment out ko na to. And then i-plot natin. Run natin from AO to plot. Okay, so magkakaroon tayo ng panibagong object. Ang tawag sa kanya AR1 small, pero 100,000 observations siya. No? 100,000 observations. So, tinan yung plot natin. Masyado na masinsing kasi 100,000 yan eh. Okay? 100,000 siya. So let's now get the ARIMA model for this one. Ito, using the forecast function. Control Enter. All right. Take a look at now at our, di ba? 0.1 na, no? Malapit na. Okay, because you have a better sized data. The mean is practically 1 then, tapos the AR component is almost 1, no? Okay? And you can, of course, try also. Sige, tingnan natin class, no? Let's plot, copyhin natin yung, ano, yung ACF natin dito, tsaka PACF. Ito na lang. Copy this class, please. Ito, yung AC natin. Let's copy this. Controls. Sige. Control C. Lagay natin dito sa simulated, ano natin. Here, I'm going to put it here. Control V. And then let's replace this by AR1.small. Tingnan lang natin class kung how does the ACF and the PACF look like. No? Control Enter. All right. Okay, in this case, hindi masyadong kita yung ano, no, yung hindi masyadong apparent kung AR or ano kasi parehong may significant ano dito eh. So let's use the other plots. No? Yan ang disadvantage mo minsan ng AC ng TSM. Masyado din maliit yung ano. Let's make use of this one. Ito gamitin natin class. Control C. I'll put it here below. And then I'm going to replace this by part AR1.small. This one also AR1.small. Okay? So, i-run natin itong ACF at saka PACF ni AR1.small. Tingnan natin kung if we can, okay, if we can indeed see yung pagiging ano niya, no? Saan na siya? Nakopy ko ba? Wait, parang wala. Wala. Control V. Na-delete ko yata, sorry. AR1.small. And this one, AR1.small. Okay? Anyway, I won't mind the title, no? Okay, so I'm going to run this, Control Enter. Okay. Could not find function AC. Nasa, di ba kanina rin na natin yung Michael? Yung TSM yun, di ba? Ito. Ito yun. If could not find, subukan mo na lang ilagay yung TSM as a namespace, no? Namespace niya. Para mag-run siya kahit hindi ano. Or you should have already installed TSM para mag-work yan. Okay, so hindi siya apparent din dito, no? Ito, this is, tingnan nyo to class yung ano. This is log 0. So AR1 siya, di ba? So dapat makikita natin dito sa PACF niya dapat. Dapat significant siya at log 1. But here, it doesn't seem to show that yung significant, wala ding significant dito eh. Pero dito, sa ACF, no, significant siya. Okay? Significant siya at log 1. So, you might be thinking na ano na parang MA1 process siya, di ba? Kasi sa MA class, ang tinitingnan natin yung ACF, yung autocorrelation function. Okay, dito, wala na, insignificant na lahat sa PACF eh. Di ba? So, if we were using the ACF and the PACF, we would have, just based on that, we would have wrongly interpreted or wrongly suggested that yung AR1 that small natin is an MA process, no? Remember class, pag AR, ang tinitingnan natin, ang focus natin yung PACF, di ba? Kapag pag may cut-off dyan, tapos tail off dito sa sa ACF, then AR process yun. Pero ito class, ang pinaplot ko dito yung AR1 that small, di ba? And this is an AR1 process. So bakit kaya ang lumalabas na ano? So those are the quirks class. Those are the quirks of the ACF and the PACF. Okay? So buti na lang nga lang class, meron na tayong models ngayon, meron na tayong software ngayon na which we can easily do that. No? All right. So for this one class, okay, ito, ang ginawa ko naman dito class, ginawa kong 0.9. So let me just share this with you para in the interest of time. Okay, we have a few more minutes. I increased here naman delete ko na muna to. I increased here the coefficient of your Control C. Chat natin. The coefficient of the okay. All right. So same class, we have actually hindi natin kailangan tong A sub O, no? Kasi meron tayong AO existing. So set that seed ulit, and then we're naming it AR1 large. Ulit ARIMA simulation, N is equal to 500. Model is equal to list natin, AR is equal to 0.9. Okay, this time our phi1 is 0.9. Standard deviation natin is, ano ba yung ginamit natin kanina? 0.1? Sige, 0.1 na lang. And then plus a constant A sub 0. Then ipa-plot natin to. Okay, so if we run this, we should have the same values kasi nag-set that seed tayo. And then ito yung ano natin, AR1 natin, no? Okay, notice that compared to AR1 that's small, yung variance ito medyo mas malaki-laki, no? Kaysa yung AR1 that's small, where the variance of your data set is a bit smaller, yung plot niya. So saan na yun? Si AR1 natin. AR1 small, where are you? Ito, no? Plot AR1 small. Control enter. Kasi naging ano na to, no? Naging 100,000 na, no? Okay? So anyway, makikita niyo yung variance niya. Ito. 4, -2, as compared to this one, umaabot ng even 6. So mas malaki yung spike nitong pag malaki yung fee 1 natin. Alright, so let's now, so create na natin to, no? And then i-forecast na natin siya, class. So our forecast will be, yan, itong using ang constant natin 0.86. Okay? Quite close, 0.9 kanina, di ba? Right? Ang mean natin 1.3127, ang ginamit natin 1. Okay? So it's because 500 lang yung ano natin, yung observations natin, relatively small. Kung linakihan natin yung class, mas ma-approximate na talaga yung 0.9. All right? Okay, questions, class? Questions? Almost time. Okay, questions, class? No questions? Clear so far? We'll end it here. Okay, so next meeting we'll go to the MA. We'll take a look at an MA process. Tapos tingnan natin yung ARMA process. Okay. So far, class, we have actually modeled na, di ba? Alam na natin i-determine yung AR or MA or ARMA process. So next meeting, we will just finalize this, no? Yung prediction na tayo, no? I-predict natin. And we have to know how to revert to the original data. Kasi pag nag-predict tayo, if it's the returns, pag returns class, no problem. Returns na rin naman yung ano eh. If we're modeling the returns, when we predict, it's still the returns. But if you're predicting the prices and you're using, let's say, the difference, anong gagawin natin? And then finally, diagnostics, titingnan natin class, yung diagnostics. Kasi dapat, just like regression, dapat yung diagnostics natin class, dapat hindi homoscedastic yung residuals natin. If there are so many spikes, there are so much volatility, then class, we will need to do something. Kasi it might mean that your ARIMA model is not able to address the volatility. Okay? The volatility of your data set. So, pag ganun class, anong gagawin? Enter the GARCH process. Okay, kung hindi kayang i-model ng ARIMA class because of the volatility clustering, especially kunyari during the crisis, kunyari COVID, o kaya yung global financial crisis. So grabe yung ano nun, grabe yung volatility clustering. And that is usually cannot be modeled using by using ARIMA. And there's another model that can do that, which is the GARCH model. Okay, yun ang susunod nating class, no? After ARIMA, we will do GARCH. Okay, so let me stop recording now.